basic conversions, and we also cover the constancies question, right? So right now let's start with the type 1 kind of question, that is find the average speed. It can be subcategorized as equal distance problem or it can be equal time interval problem. Let's start with the equal distance. You would have seen questions like this probably. So if there is a station A and there is another station B and there's a person, okay, and he's going to travel at a speed of 40 km per hour. Of course, yes, he's not going to walk at a speed of this much. So he's going to travel at a speed of 40 km per hour from A to B. And then he's going to return back at a speed of 80 km per hour. Okay? So they can ask you to find the average speed of the man. Okay? This is a possible question that you would have come across more frequently. So how do you find this out? This is an equal distance problem. So why am I calling it an equal distance problem is that because he is traveling the same distance d with two different speeds. Alright? So I can rewrite this question, right, in this format. So this is one distance d and he is traveling it at a speed of 40 km per hour. So the other return journey, right, I am trying to bring it this way. So the return journey is of the same distance d and he is going to cover it at a speed of 80 km per hour. Alright? So let's consider this as S1. Let's consider this as S2. So what is speed average? We know the speed is nothing but what? Distance by time. So speed average is nothing but total distance by total time taken, right? By total time taken. So here, what is the total distance? The total distance is d plus d, alright, which is 2d, d plus d. And now total time. So here there is no component of time involved at all, alright. But we know that speed is equal to distance by time. So time is what? Distance by speed. So I can rewrite the time here to be as d by s1, alright. Similarly, for the total time, the time duration for this is going to be d by s1. But its time duration for this is going to be d by s2. Alright, so this is going to be d by s2. So it is going to be 2d, and here I am taking d common off. So it is d 1 by s1 plus 1 by s2. So cancelling of d both numerator and denominator, what do you get? 2 into 1 by s1 plus 1 by s2, the whole inverse. So this is the formula of this. So if I substitute s1 and s2 as given here, so it is going to be 2 into 1 by 40 plus 1 by 80, the whole inverse. Alright, yes. So that is nothing but 2 into 2, multiplying 2 on both sides. So it's going to be 2 plus 1, 3 by 80, the whole inverse, which is nothing but 2 into 80 by 3. Alright, which is 160 by 3 km per hour is going to be a speed average, right? So if I am going to generalize this, suppose that there is 2 here because the distance here is divided into 2 parts. Suppose that instead of this, it's going to be like 4 parts. Like, okay, this is one d, this is another d. It doesn't look like d, but I want this to be d as well. Okay, all of these are equal distance parts. So, and the speed here is s3 and the speed here is s4. What I mean by this is that the person here is going to cover a distance of d with speed s1. The other distance, same distance d with a different speed of s2. And the third distance d with the other different speed of s3. And lastly, same distance d with a different speed of s4. So the thing is that it's equal distances, but it's different speed. Alright, so for this question, right, it is going to be 4 into 1 by s1 plus 1 by s2 plus 1 by s3 plus 1 by s4, the whole inverse. This is speed average. So you understood, right? Why is it 4? Because the distance is 4 parts. Alright. So suppose that if I am going to generalize it in a more prominent manner, how can I generalize it? I can rewrite it as n into 1 by s1 plus 1 by s2 plus so on till 1 by Sn, the whole inverse. So this is going to be my speed average for n parts and distance d. There are n d parts that's actually available. Alright. So if at all you didn't understand anything right now, right, it's totally fine. Alright. So just make note of this formula. We will look into a few more questions so that you can understand it in a more better and a prominent way. Right? Yeah. Let's see the question. So question 1. A person covers 1/3 of the distance at 40 km per hour and and the rest of the distance in 80 km/h, find the speed average. Okay, it's a very simple question, alright. So a person is said he's covering 1/3 of the total distance. So if this is the total distance, he's covering 1/3 of that distance at a speed of how much? 40 km/h. And the rest of the distance in 80 km/h. Okay. So the totally he's going to cover it at 80 km/h. I'm going to apply the equal distance problem. So what I'm going to do is add this. I'm converting this to also be a distance of 1/3. This to also be a distance of 1/3. So equal distances. Alright. Can I write this as this format as well? The question can be rewritten like this. A person covers 1/3 of the distance 40 km/h and the rest of the distance 80 km/h. This again 80, this again 80. It means the same thing, right? So now you know the formula. Speed average is nothing but what? N into 1 by S1 plus 1 by S2 plus so on till 1 by Sn, the whole inverse, right? So how many parts are there? 3 parts. 3 into 1 by what is speed S1? 40 plus 1 by 80 plus 1 by 80, the whole inverse, right? 1 by 80 for this, another 1 by 80 for this. So 3 into 1 by 40 plus 2 by 80, the whole inverse. This becomes 1 by 40. So 3 into 2 by 40, the whole inverse, right? So that becomes 1 by 20. It is nothing but 3 into, this becomes an inverse, so 3 into 20, which is 60 km/h. Alright, so that's your answer for this question. So let's go to the second question, right? So let's consider this question. A train covers first 1/5 of a distance at speed of 40 km/h and last 1/5 of distance at speed of 80 km/h. The mid period at a constant speed of 20 km/h, find the S average. So as soon as you read a question, the first step is to write it down literally. Fine. A train covers first 1/5 of a distance, so fine, there is some distance d and it's covering first 1/5 of a distance. Okay, so towards the entire distance d, the first 1/5 is covered at a speed of 40 km/h. Fine. Second statement. And last 1/5, alright. So suppose this be the last 1/5, okay, with a speed of 80 km/h. Alright. So mid period at a constant speed of 20 km/h. So this is the middle range. It is getting covered at 20 km/h. So as you can see, this is what? This is an equal distance problem. So how can I write this to be as? This can further be divided as 3 1/5 parts. So this is also 1/5, covering with a speed of 20. This is also 1/5. This is another 1/5 part. This also is getting covered at 20 km/h speed. Can I write it in this format? Right? So we know that what is S average formula? S average for equal distance is nothing but N into 1 by S1 plus 1 by S2 plus so on till 1 by Sn, where N is the number of parts the total distance is divided into, right? So what is N right now? N is 5. So it is 5 into 1 by Sn. So this is S1, S2, S3, S4 and S5. So 1 by Sn is what? 1 by 40 plus 1 by 20 plus 1 by 20 again plus another 1 by 20 plus lastly 1 by 80. This is the whole inverse of it. The whole inverse. Alright. So let's simplify it, which is nothing but 5 into 1 by 40 plus 3 by 20 plus 1 by 80, the whole inverse. The denominations can all be converted into 80 itself, right? So 40 into 2 into 2. And this is into 4 into 4. So this is nothing but 5 into 2 plus 4 3 are 12 plus 1 divided by 80, the whole inverse. Don't forget the inverse, okay? So it is 5 into 12 into 15. 15 divided by 80, the whole inverse, which is nothing but 5 into 80 divided by 15. So 5 3s are 15, which gives us the answer of 80 by 3. 80 by 3 is approximately 2 Okay, 26.66, so it can be written as 266.67 kilometer per hour. So answer is going to be 26.67 kilometer per hour is going to be what? Our speed average. Speed average is 26.67 kilometer per hour. I hope you understood this question. See you in the next question.